Swayam Prabha. Digital India. Educated India.
Okay, good morning. So it's my pleasure to be here with you. So I'm going to continue our sort of general introduction, but I'm going to sort of talk a little bit more about the circular economy, circle, cradle to cradle type economy, and which is a little bit getting into a little bit more in depth compared to what Indu showed this morning. And so just to get started, I do want to point out, I don't know if Bindu mentioned it, but you might not have all heard it, that you will be getting copies of all these slides. So I know some of you are taking a lot of notes, but you can take some notes and not have to worry about capturing quite everything. And there will also be recordings. I don't know if they'll be available to everybody. But first, I just want to start with a little bit of geography. So people that think about New York State, this is New York State. New York City is way down at the southern end. I live close to Canada. So it looks like the map ends at this, but that's just because it's Canada, not the United States. So I am from New York State, but not from New York City. And sometimes when you say New York, everybody just assumes it's a city. So it's a very small community. So it's far up north. And we will be talking about New York State. I know that we're bringing a lot of Indian perspective into this, but I'll also share with you some of the US perspective as well throughout, because that is what I am most connected to, but also on the third day, when we talk about energy systems, your role play activity will also be about New York City. So I just wanted to start a little bit about sort of the science of sustainability. We've already talked about the science of sustainability. And you just showed this sort of three main pillars. I just want to show you another way to think about it. So one of the things that's really important about sustainability is it's all about the future, right? And thinking about those planetary boundaries, and that we need to do something now because we're already dipping into generations in the future. We're dipping into their future. And so sustainability is always about sustaining something now so that it is available for the future. Sustainability is a very human-centric approach. Even though we talk about biodiversity and saving the planet, it is for the good of humans, is really what sustainability is all about. And that bothers me sometimes, right? It's not nature just for nature's sake, but it is really all about the human perspective. And it also includes social responsibility and quality of life. As I said, limits to our natural world. But this bottom picture is the way I like to think about sustainability. This is sometimes called strong sustainability. And I like to use the word prosperity as a measure of economics rather than profit. So prosperity means that, you know, we're making enough, we're doing enough, we're doing well enough without gobs and gobs of, you know, comment about the ultra rich and things of that sort. So you can't be prosperous unless if you're in a healthy community or a healthy society, and you can't have a healthy society if you don't already also have a healthy planet or a healthy environment. And so rather than thinking about balancing all those and sustainability being that little triangle in the middle, it's really about all of these together. That if we really want to truly have prosperity, we need a healthy planet and a healthy society. So I go with the strong, and I was corrected on this many years ago by an environmental ethicist, pointed me to this direction for sustainability. It's a little less human-centric. So you've seen the Sustainable Development Goals, you know a little bit about them. 17 is a lot to remember, so I sort of chunk them into 4 groups, and this is not perfect by any means, there's overlap. But the basic things that we think about when we think about sustainability is quality of life, right? That human element, the healthy societies, environmental responsibility, what we have to do to keep the environment safe, equity and equal opportunity for all, and prosperity for all. So these are really sort of the words that go with this strong sustainability output. And still, this is a lot to remember. But if you look at the United Nations webpage and you dive into the details of some of these sustainable development goals, you see an awful lot that relates to what we're doing here. So for that quality of life, certainly the role of circular economy and life cycle thinking are critically important in meeting these. So reduce the health impacts from hazardous chemicals, water quality, so we've got less water pollution, increase water use efficiency. These are all things that we're going to be talking about, and they are in the details of the SDGs. For environmental responsibility, certainly energy efficiency and renewable energy is an aspect of that. I will be introducing New York State has a fairly aggressive climate law. I'll be talking about that for a little bit. I've been pretty immersed in that, but really meeting the decarbonization of the future that we need to meet the climate goals. So there are 3 key words there that we'll dive into more on Wednesday. And then in the equal opportunity, we've got economic productivity, diversification, technological innovation. Engineers come into play a lot here. But the bottom line here is, how do we do what we need to do for a healthy and prosperous society without depleting the environment? And I heard several words. Biofuels, green hydrogen, all of those things, words that I heard some of you say are all important for what engineers need to do to figure out how do we maintain that prosperity and good, healthy communities without depleting all the natural resources. And finally, in prosperity for all, responsible consumption and production. These are some of the words that are in the details of the SDG. Environmentally sound management of chemicals and waste, reducing waste, adopting sustainable practices, and information reporting. And Indu spoke of many of those things as she did her introduction. So it's in the details of the SDGs too. The SDGs are not just these lofty goals with no hunger type words. There's a lot of details of what exactly we need to do to achieve those. And it might be worth, if you haven't read the details, to go in and see what is it that overlaps with what you do or what interests you. So that's still just part of that introduction. When we think about what sustainability is, and the UN Sustainable Development Goals captures that strong sustainability sense that we need to move forward. So let's just talk a little bit about how we got here. I'm going to give you a little bit of history and back perspective. This is what our old and even some of our current industrial societies looked like. Extracted materials from the use, make them into a product, use the product, and throw it away. A very linear approach to what we do. Everything that we do used to fit into this line. And so this is what a circular economy is going to challenge, this linear approach. So we're going to start right now. I am going to put you to work for a couple minutes. So if you're sitting alone, you might want to find somebody to sit next to, just so that you have somebody to chat with. If you've got pencil and paper, that would be great. We're just going to start thinking about the lives of products, right? That's what this course is really going to do. Processes and products, what they are, how we use them, why we use them, and what's going on. So this is just your first step. And you all know what this is, right? Number 1, PET plastic water bottle that is intended to be a single use. We don't always use it that way, but it is a single-use plastic water bottle. So I just want to give you 5 minutes at the most to talk through these questions. You've already answered the first couple. So talk amongst yourself for just a few minutes. See if you can answer these questions, because this is about life cycle thinking, right? You got to be able to think. So I'm not going to do all the talking. there are potential health impacts if you use the plastic bottle multiple, especially like if you leave it in your car and it gets hot or in the sun. So yes, there are challenges with reuse. Okay, so it's only used once and it's hard to use more. It's hard to make this particular product more efficient in our use, but it does efficiently get you water, clean water when you need it. So we got to be careful when we think about what does efficiently mean. So what happens to it when you're done? Landfill? Anyone else? In the ocean? And it ends up in the ocean because what are the steps in between? You and the ocean. Okay, so it might be recovered and separated. They're probably not making another water bottle out of it. So there's some downcycling, right? But we're still getting some material value out of this. Anything else? Incineration. So it's a benefit of incineration. But you get electricity because you're capturing the energy value, right? There's, energy, it's organic molecules, they can be combusted and you get heat energy that you can make into electricity. All right, so this is an example, and we're going to use this example tomorrow as well, because it's something that you're familiar with, right? It's not the new technology like green hydrogen, right? That would take a lot for some of you to learn, but you know enough about plastic water bottles that we're going to use this as an example over the next few days. So, and finally, does its manufacture, use, or disposal cause any environmental impacts? We've already said it ends up in ocean, and the consequence of that is marine wildlife are damaged. It breaks down, right? It does not biodegrade, and it really doesn't, the material does degrade, but only into like smaller pieces of plastic. It doesn't break down to like carbon dioxide and hydrogen or methane or things of that sort, but it does, it just breaks apart. So it more disintegrates rather than degrades. So it does disintegrate into smaller parts, and that has all sorts of impacts on marine wildlife. And then ultimately what we just saw in the previous presentation, if you eat fish, it can also have a public health impact as well. Any other environmental impacts? Okay, a lot of water use. Energy is used in its production. So there's going to be transportation, and what's the result of transportation? Okay, so all sorts of combustion emissions, right? Carbon dioxide and greenhouse gas emissions, but also things, particulate matter, NOx and SOx, ozone, photochemical ozone, smog formation. There's all sorts of impacts there too. Extraction, right? So what might be the environmental impacts of extraction? So what are we extracting? Oil, right? So we're extracting oil, and the environmental impacts might be methane emissions, absolutely. Have any of you seen an oil spill? All sorts of environmental impacts, including back to that marine wildlife. So this is what we're thinking about, right? So this is your very, so tomorrow we're going to go into a lot more depth on this, but you already know a lot about thinking about the life cycle, thinking about the whole system. That's truly what sustainability is about, and what hopefully, even if we're going to be brief on, we're not going to be able to do a life cycle assessment in 10 days, but we will get you to the point where you know how to think about it and you have some of the tools so that you can go learn more. But this is a good start. So you know how to think about the life cycle. We heard everything from extraction to end of life, which is great. So now if we want to, we saw the linear economy, right? Now if we want to think a circular economy, very different from that linear economy. What do we see here? We see that there is, yes, where's my mouse? Some material extracted from the earth, but probably fewer in a circular economy. It goes to production. You can just imagine that this is that water bottle. We've got consumption. Hopefully we are reusing aspects of that, recycling. So the recycling can go into secondary production, like the fibers for your fleece jacket, or it can be made into some other, but that secondary production might still need some resources extracted from the earth, and still might create some waste, but there's a lot less waste going into the earth and a lot fewer resources extracted from the earth. And there's all of these circles. That's what a circular economy is. Imagine circles instead of that straight line. That's the key, the fundamental to what we will be talking a lot about. So, and some of the aspects of this, some key words when you think about a circular economy, we have durable products. So they're not things that you just use once and throw away. I see lots of water bottles on the table, the ones that were provided, but also others. They are durable. They are meant to be reused for a long time. The metal ones I found are the most durable, but there's also the most materials in them compared to like a polycarbonate or an Algene bottle. So there's something that we can maintain. I'm having a challenge twice in the last week. I've broken the arms of my glasses, and like a little bit of super glue can help a lot, but these are going to fall apart again before I get home. They are not made to be repaired. They are made to be, buy a new pair of glasses when you get home. So it's not really a circular economy. Do you know why this is? Glasses now have these spring-loaded arms, right? So I don't know if some of you have glasses. Do you have spring-loaded, right? They snap down. That's what makes them not durable. They're very convenient to us. Spring-loaded arms, not durable. So yes, do you have spring-loaded arms? They snap down, not durable. All right, and therefore you can't repair them, right? So if you can't repair them, they're going to leave that circular loop. I cannot, when the prescription goes out, I cannot donate these for somebody else to use these glasses, which is what used to happen with old glasses, is that they went somewhere in the world where they needed glasses, but can't even do that anymore with these. And so reuse, refurbishing, recycling, those are all key words. And there's some priorities to the benefits of some of these are a higher priority than others, and we'll get to that in a minute. So the circular economy principles: eliminate waste in production. Now, we're never going to eliminate it entirely. Thermodynamics, right, tells us that there's always waste, at least some waste energy. There's always going to be some material waste as well. We cannot eliminate. And so ideas like the zero water discharge is really hard to achieve to get to zero. It takes a lot of extra energy to get to zero. So circulate products as much as possible. Or if it's not the product, then it's the material that's made out of that product as much as, and think about regenerative nature. And that's back to using renewable resources within the carrying capacity of the earth to renew those resources. So all of those things. So renewable energy, renewable materials, the bioeconomy rather than the fossil or abiotic economy are all really important aspects in this circular economy. So the class I teach is called industrial ecology. And has anybody heard that term? It's sort of getting outmoded now. It's not used very often, but 25 years ago, when I first started teaching this class, it was like the in word to use. But basically, that's the science of sustainability. A circular economy is actually the system, right? So we have the system where all these materials and energy are recovered and recycled and reused. And then we have the science of how do we study this? And that's sometimes called industrial ecology. So that's a field of study. And it's thinking about industrial systems the same way we think about natural systems. So how many of you have had a recent course in ecology? A few of you. All right, the non-civil environmental engineers. Okay. Well, I found in the United States, our own students and environmental engineers do not learn ecology, which I think they need, right? Because that's what we're trying to do. We're trying to think about operating a planet in the same way a natural ecosystem is run. And that's basically what a circular economy is. Can we devise industrial systems that mimic natural systems? So natural systems, we have all these interdependent parts, right? Atmosphere, biosphere, lithosphere, geosphere, they all are interconnected, right? That's a critically important part of industrial ecology or circular economy, is that they are all interconnected. This is like a fifth grade, at least in the United States, fifth grade science, right? You learn about producers. Producers take carbon dioxide out of the atmosphere. They make wood, right? Photosynthesis, they release oxygen, critically important in the biogeochemical cycles of our world. Consumers eat those, they die, they return to the earth, their nutrients are back in the earth, and then the plants can take them up. It's a very, very circular system. So circular economy is based on these natural systems. So the key words here are interdependence amongst these systems, cyclic, so there is no waste, right? Even animal waste or decomposing body in the woods becomes nutrients in the soil for, or, decomposers, microbes and other things, worms, they eat the decomposing material to return nutrients to the earth. There's always going to be energy in, but that energy in comes from the sun, right? And there's always going to be energy lost. That's basic thermodynamics. But otherwise, it's this interdependent cyclic nature. So this is largely US based, but I just want to give you some idea of how far we have come in just 50 years or so in terms of thinking about moving towards that circular economy. In the United States in 1970, that was when the US Environmental Protection Agency, or EPA, was established. That was the start of our Clean Water Act, which I just read is getting gutted, our Clean Air Act, all of those the Endangered Species Act, those all came out of the 1970s, at least in the US. So, but it was this circular economy, right? Even though it's in a circle, it's like you're taking resources out of the environment and you're putting waste back into it. You're not circulating very much. So that was sort of before 1970s. And with industry, we put even more industrial waste, this toxic waste, into the environment. So we expected that carrying capacity of the earth, which we just talked about, was sufficient to absorb these waste. Well, it wasn't. And so that was why in the United States, we started regulating a lot of these things. Later, usually mostly the 80s and 90s, we started to think about end of pipe treatment. And that's what a lot of environmental engineering is based on, right? So you don't dump it into the water. You've got a pipe, you treat it, and then you dump it into the water, or you recycle it in India now in the zero water emissions waste. So now we've got treated water going back, or treated air going back into the atmosphere. It's very, very expensive to think about an industry system that you're treating at the end of the pipe. And it caused a lot of discord between the regulators and the industries because the industries couldn't really do it well enough. And it was costing them a huge amount of money. It was not economically viable to have end of the pipe treatment. Pollution prevention came in the later 90s and 2000s. So it was the idea that, well, if we don't create the pollution, then we don't have to clean it up. And so that might have been less toxic materials so that you don't have the challenge. Recycle internally, recovering materials and reusing it internally all became part of sort of the pollution prevention aspect. So there was now less treated wastes going into the environment and less disposal, but not none. And then finally, I'd say since about 2000, last 20 years or so, really this more circular economy and industrial ecology approach, where there's see all those recycle, reuse, renewable energy. So there's a lot more of this thinking. So this is not something new. There has been an evolution towards this based on the fact that when we tried to clean up the environment by thinking of end the pipe treatment, we realized it was not an efficient and effective approach. It was not sustainable. It was not sustainable for the industries. It was certainly not economically sustainable. And so we've moved towards a system that now is a lot more. So it's just using a lot less harmful materials and recovering and recycling and looking more towards those renewable materials rather than the non-renewable materials. So that just gives you a little bit of sort of historical perspective that it hasn't been that long that we've been talking about these things. And learning the tools, which we will cover some in this class, to do this is important. All right, so what is the current typical model in India? Is my question. I already learned about the zero water, right? Zero water discharge. Anything else in India right now that's happening, or this state? Renewable energy. All right. A lot of solar, mostly. Hydropower. Okay. All right. Anything else? So using renewable resources. Heard also subsidies for solar power. Okay, so green paints, less toxic. So that's a pollution prevention approach, right? If you don't put toxic materials into your paint, you're not going to have to deal with the residue as a hazardous material, right? It's more water soluble. So green paints. So there's a lot of this effort. Green buildings, okay, and green buildings are green because, all right, so how we use the energy, not just where it's coming from renewable resources, but we're using it more efficiently. These are all key words that are important in a circular economy. All right, so let's look again. So we got this closed loop natural system. How are we going to make that into industrial systems? So we've got something for everything, and I'm going to share with you a couple of different models for thinking about a circular economy to get to this picture. So how do we get from the left to the right? So originally, this is what I think is sort of the mastermind. So it's in 2002, a book called Cradle-to-Cradle was written and distributed. So, as I said, last 20 years or so. It was even printed on paper that came from bamboo or some more rapidly renewable resource than tree paper. So they were really thinking about even how are they going to print the book and the ink that they use. So it wasn't just the concepts in the book, but it was actually the book, the physical book product itself. So they came up with these two circles. On the left is the biological circle, right? So on this, we sort of see two separate systems, right? We've got our natural systems and we have our industrial systems. And one of the keys to circular economy is to put them together. So we still have that biological circle. And now we've got to think about how do we interconnect that to our industrial circle. And you can see these, the red words and these little arrows I added because in 2002, we were just thinking about this one big circle. But in reality, it takes a lot of little circles inside as well. But some of the keys from biological systems, we often get non or less toxic materials, not always, but often. There is some, after disassembly of waste and separation, some materials that go back to the biological processes, but the idea is most of it stays on the right-hand side. And the concept is no waste. Everything is a resource for something else, just like in a natural system. So these are the 5 tenets of the cradle to cradle. 100% renewable energy, right? So that all sort of emanates from the sun, except for nuclear, which is, or I'll say geothermal, heat from the earth. Water stewardship, clean water output. So that's, India's doing that a lot. Social responsibility and a positive impact on community. So the people are important in this. Material reutilization and compostability, and material health impact on making it non-toxic, both for humans and the environment. So these are the 5 tenets that were laid out in this book in 2002, which was sort of what I feel is that these were the fathers of this idea of circular economy. And so we're sort of trying to get away from this linear system. So we've got to think about the human's role in all of this, right? We are a very anthropogenic, human-centric system. We've got lots of systems in here that we have to think about how can we change all of these systems. We just heard about buildings, right? buildings and roads and products, agriculture. I heard some mention of bioproducts and biofuels earlier. The manufacturing sector, service and information. I'm sure data information and data centers and AI are booming. What does all of that take? Water and electricity. So the United States, some of these data centers are building their own nuclear power plants because it takes so much energy to use AI. Don't use it if you don't have to use it. There are good roles for AI, but don't let it find a recipe for you or something like that. Use it when you really need it. So we have the information industry is becoming increasingly detrimental to the environment just because there's so much of it and all of those semiconductor chips. And then, of course, there's the energy production industry. We need to think about all of these systems together in our systems approach to think about this product life cycle from resources to waste. So I've already covered all of these, but there's lots of changes that we need to make, and we need to make it to all of those systems. And we've heard, right? We heard renewable energy, we heard green buildings, we heard green products. What else do we hear? Nobody mentioned information industry yet, but it is a big part of our future. So let's get back to why we're doing this. And the real problems we are addressing, we already got an introduction to it, is that we don't consider the whole life cycle, right? We just consider end of life. And often with water bottles, so you are already advanced. When I talk to my first year undergraduate students, the only thing they know about water bottles that's bad is litter. And the marine, that's what they think the problem is. They don't understand life cycle thinking. So all of you did a much better job, which is better than my 18-year-old first-year students. But we have to think about that whole life cycle. So it's resources extraction, manufacturing, energy, consumer use, transportation. And the problem is that if we fix one of these, we end up messing up something else. Does anyone know about something that we tried to fix that we made worse? All right, I'll give you an example. Talked about the ozone hole, right? We just saw the ozone hole. It's great international cooperation, environmental regulation. We banned chlorofluorocarbons, which are the primary, the chlorine goes to the ozone layer, 30,000 feet above the atmosphere. It reacts with the ozone and it creates the ozone hole. What did we replace those with? Hydrofluorocarbons. What was the unintended consequence? So the unintended consequence was we came up with a solution for something that still met the chlorofluorocarbon need, its use in industry. It's very non-flammable. There's all sorts of reasons. It's used in sprays, aerosol sprays. We came up with a solution that still met those industrial need, but we created a new problem. Greater contributions to climate change. Ozone hole is recovering, climate is not yet recovering. So what question did they not ask? You guys had the answer for the plastic water bottle. What question did we not ask during that Montreal Protocol in 1985, I think? We think about the system. Do we need aerosol sprays, right? Maybe we can live without even having HFCs. So now that there's all sorts of, they're used in refrigerants too. That's a big part of where they're used. Using ammonia for refrigerants. Well, that's a health hazard if there's any leaks. There's still all sorts of challenges. But we have to be, if we don't think about the whole system, we solve a narrow part of the problem, we don't understand the big problem. And I would say that back to Professor Indu mentioned that we both started on groundwater remediation. I will tell you, when I recognized that there were things that were more important than groundwater remediation was because of that. In the United States, trying to reduce air pollution from automobile emissions this was in the 90s, they added a chemical MTBE, methyl butyl ether, to the gasoline to help improve air quality. So the gasoline burned more completely and there were fewer hazardous substances in the output. And then they said, oh, well, what about the groundwater? It was not part of their solution. And it ended up that MTBE is sort of almost a forever chemical in groundwater. It is not biodegraded and it's very mobile. That's what made me think about these unintended consequences. And it has bigger problems. Then we started adding ethanol to our gasoline, and that created all sorts of other problems. So we have this history of looking at a narrow part of the problem and fixing what we think is the problem, but not getting to the real problem. Right? Maybe that real problem should we be combusting so much gasoline, right? That's more the real problem. So it's thinking in this ways where we think about the whole system so that we don't have this series of unintended consequences. All right, so we still have all these challenges. I'm sorry you can't see the bottom row there. We still have all sorts of environmental degradation. All right, so the systems perspective is what we really need to think about. And so we will be covering this. Again, this is just intro. Is the product initially designed to minimize impacts, right? So we've got to start at the beginning of the design process. Do the industrial manufacturing processes work? Are they the most efficient? Are they the cleanest? What are the life cycle impacts at every single of the stages from extraction to end of life? How can we change these processes to improve? This is what we're going to cover in this class. These are the questions that we're going to ask ourselves and each other every day about all the different examples that we're going to share with you. All right, so here's another sort of framework. I showed you the cradle to cradle. That was the first sort of thinking about a circular economy. That Ellen MacArthur Foundation, does anybody know the Ellen MacArthur? Is that a name that you know? Well, the MacArthur Foundation, the name MacArthur just in general, very rich people in England. She actually was the first woman to sail around the globe, was her claim to fame. She's very rich, right? She had the money to make that happen. But she did it. So but she also saw a lot of damage and degradation as she did that. So she set up this foundation all about a circular economy, all about thinking about how do we do better. And so it's the same. It's just another picture of the same thing, right? So I've given you several different pictures to hopefully that they will start to get to you. So again, on the left is the biosphere. And this is where our biomaterials come from, that bioenergy, the green hydrogen, all sorts of things like that. We've got the biosphere. And then on the right is the technosphere. My E got lost there, but technosphere. So we have all of these circles. Starting with, if we think about just the technosphere at the beginning, that we want to share and reuse as much as possible. Refurbish, remanufacture, recycle, that's sort of the outermost circle. That means it's the lowest priority. So we want to do those things that are closest, smallest circles first, right? That's the reuse, whether you reuse it yourself or I don't know about here. Do you have thrift shops for clothing? Yeah, right? That's a way to reuse, right? You don't want to wear your clothes anymore. Maybe you don't have as much fast fashion as we have in the United States, but our college students go through clothes like every year, the women at least, buy new clothes every year, right? But at least now it's going to the thrift store so somebody else can buy it and reuse it. Because I don't know, you get tired of your clothes after a year. I don't know. Anyhow, there's ways of sharing, and it increases. My kids only shop now in thrift stores. They just recognize the value of it, especially to their pocketbook. But it is a good way of thinking. So the Ellen MacArthur Foundation. So we have this sort of priority list from the inside circles to the outside, if we're only thinking about the technosphere, that abiotic side, all our non-biologically oriented material. So we've got this double cradle loop. So this is the metals, fossil fuels, all of those things. And there's economic value to keeping it small, right? Every time you have to go back and extract more materials, or whether they be for energy purposes or to make products and good, that costs money. The more you can keep it in close, you're still getting economic value out of that material without adding a lot of cost. So it's good for the environment. It's also really good for prosperity. So we want to keep those things in the economy for the maximum amount of time. So we've got our priority list here. The words are pretty self-explanatory. I'm going to ask you to think about these words in a minute. But the more we can repair and reuse, the better. If we can take things apart to reuse parts of them, that's okay. Reassembly, right? Put them back together, like something like this chair. What happens? The wheels break. Well, take that broken wheel off, put a new broken or new not broken wheel on, right? If there's repairability is really important. And the biggest one is recycling is the lowest priority, right? We always think, oh, it's great, we're recycling all this stuff. Well, not so great. Better to not get to that point where you have to recycle it. Recycling is better than landfilling, but it is the lowest priority of what we should do with our meat, because it takes a lot of energy and a lot of water and sometimes a lot of hazardous chemicals to break those materials back down to their starting materials so we can make them into new materials. Better than not recycling, but not as good as the other actions. So I think I'm going to skip this one. And then we've got the bio side of the circular economy. And this is the idea that there are renewable bioproducts that we can use in a sustainable, at their carrying capacity, right? We can't cut down all the trees to use wood for energy or materials if we are cutting them down faster than they're growing back. Are there any materials around here that you use that grow back really rapidly that are sort of rapidly renewable? Bamboo, absolutely. Bamboo is a great example. You can make all sorts of stuff out of bamboo, whether you break it down to its fibers and make paper, fabrics, building materials. There's all sorts of things that you can do with something like bamboo, and that's rapidly degradable. Okay. So in this case, again, these cascades down in the bottom, this is what we want to do as much as possible. Here too, we want to reuse those materials as much as we can before we think about sending it back into the repurposing. This is where biogas comes into play. Some of those materials can still have energy value. All right, and then we can use those materials as well to make chemical feedstocks, as well as just the fiber and the material structural that we just mentioned out of bamboo. All right, and then recovering energy, anaerobic digestion is very appropriate. Okay, skip this one too. All right, so in order to do this, I keep saying the word systems, right? We need systems change. This is everything. We just heard it sort of in another way from your first talk, right? We have to change our business systems. We have to change our government systems. We have to change how we value the environment, how we value public health, all of this, how we account, right? We talked about accounting, how we account greenhouse gases, very hotly debated topic. Farming practices, manufacturing processes, materials extraction, materials recovery, all of those systems need to work together if we're really truly going to make change. We're going to talk about all these systems to some level, but we're going to focus maybe a little bit more on the products and manufacturing, but we will get to all of that. It is hard to change at this level. So we had a question earlier about, well, a big change could be tax the rich to have enough money to cover the cost of climate change. Really, really hard change to make. And it's so political right now. I'll tell you, that would not fly in the United States at the moment. But we have to understand the complexities of these systems. So if something, all of you leave here understanding the complexities of systems and where the environmental and social impacts come from, we will be better off. Understanding, education, educating youth, educating your parents, educating your neighbors. This is where we really need to start talking about the change. Then the other changes sort of can happen more easily if people understand the interconnectedness of all lives, ecosystems, human, all the materials, goods we use. So we're going to talk about today, mostly we're going to talk in the, oops, sorry, keep hitting the wrong button. Today, we're just going to introduce this sort of circular economy topic. Throughout, we will get to the point down at the bottom. It says new concept of product use and end of life. That's a sort of cradle to cradle or circular economy. There's all sorts of green technologies, right? How do we make cleaner water? How do we make cleaner energy? The eco-industrial parks are a great topic. There's a great one in Denmark. I don't think we're going to have time to talk about it, but they're sharing the waste. Waste of one industry goes to another industry. They built the whole community, the whole industrial ecosystem based on sharing waste materials, including waste energy and clean and not so clean water. It's a great example. But right now, we are just going to talk about circular economy. So I am going to challenge you to do something. Now, I think there's two ways to do this. Do they have access to the file yet? They do. Okay, so there's two ways we can do this. If you have a laptop readily, so you can stay with your partners, this is good that you're sitting with somebody else. The Ellen MacArthur Foundation on their website has all sorts of examples of products and products that meet the sort of concept of the circular economy. So I just want you to explore for a little bit. So there's two ways to do this. One, if you've got a laptop readily available and you can fire it up quickly, you can, in the folder that you've got is a Word document that looks just like this. And at the top, there's some links to a video and things like that. We're not going to do that now, but I want you in your pairs or threesomes to look quickly at the topics, pick one, and then try to answer these questions about, what the product is, how it's used. And then I want you to think about the vocabulary words. You can add more rows here. The vocabulary words that we've talked about: share, repurpose, non-toxic, renewable. Any of those vocabulary words that you see that you think are related to a circular economy. If you don't have a laptop, you can do this on your phone and you don't have to open up the Word document. You can just search Ellen MacArthur Foundation circular economy examples will probably get you there. So by just phone is okay. But if you've got a partner, so you can go to the website. So there's all sorts of examples here. So I take, I don't know, 2 or 3 minutes to just peruse the examples, come up with something you think looks interesting. If you've got access to that Word document, it's just a place to collect your thoughts. I will put that back up here if you don't have the Word document, so you can still see what the questions are. And then like in 10 minutes, I'm not going to give you a lot of time. I just want you to sort of explore briefly. We can come back together. All right, so I will leave this up. So Ellen, so everybody's got you definitely need the website. If you don't have this Google Doc, that's okay. You can just read and answer the questions without putting it into form. We're not collecting this. It's only for your own purposes and to organize and to stay focused. So take a couple minutes to pick a topic. And you can talk together. If you've got two laptops, that's great. One of you can have the Word doc and one of you, or the Google Doc, and one can have the Ellen MacArthur Foundation open. These are all great examples of things that we're going to be looking for. And we're going to be, it's not an exhaustive list, but my point and our point this morning was to give you an introduction to like everything we're going to be doing over the next today plus 9 more days. These are the types of things that make a product fit in the circular economy. So the circular economy is the end point. Life cycle assessment is one of the tools that we use to assess if we're going to, if it is, you know, good. And we're going to be talking in more detail about life cycle assessment. We're going to introduce it tomorrow and then talk in more detail about it early next week. But to really think about that side. And then we'll get back to the circular economy. You know what, when I teach these classes, the biggest problem I have is it's circular and it's all interdependent. There is no linear process of start to finish. Like in some classes, it's very clear what you need to start with and where you finish with. And so we're going to be going back and forth between many of these topics because there is no start and there is no end. It is a circular, interdependent system, which makes it hard sometimes to figure out how to teach. So be patient. Today's all about introduction. Some of you might say, I know all this already. Maybe you do. But by the time we get to next week, Friday, when we dive into the details of some of this stuff, hopefully there will be more that you will learn. But this is getting us all on the same page. So I am going to close here. So hopefully good introduction. You saw the grand challenges and, you know, why we're having this conversation. You know something more about circular economy and the way of thinking and the models for circular economy, what we're looking for, but now we still have to think about what do we have to do to get there. So, Indu, do you have anything else to add, or Bindu, do you want instructions for this afternoon? We're trying to get you out a little bit early right now because I know that there's some housing issues and then after lunch will be 1:30 still? Is that the schedule?